All right, here is the next problem. So the next problem is sort of geometric. So we have some scenario, and we need to figure out what the how to sort of translate it into the chain rule, right? So the length x of a side of a triangle is increasing at a certain rate. The length y of another side is decreasing at again at a different rate, and the contained angle is decreasing yet at a third rate. So let me draw this triangle. So sort of the situation is like this. So there is x, there is y, and there is theta, right? So we have a triangle. Okay, so what's going on? X is increasing, right? So imagine that this point is sort of is moving towards this direction, right? So x is going to increase. Now, y is decreasing, right? So this point is sort of moving towards this direction. At the same time, the angle is also decreasing, right? Okay, so it's sort of moving towards this direction, right? So which means that if you kind of try to make a movie out of this rectangle, you would probably the next um, uh, moment this point would move probably here. This point probably move here, but since the angle is decreasing, it's probably going to look like this, right? So this is kind of the next um, sort of snapshot, and then this move this point moves here, this point moves here, and then the triangle becomes something like this, and so on, right? So you can I hope you get the idea, right? So what's going on? And the area is um, changing. We can't even be sure that whether it is increasing or decreasing. Well, I guess in the end, so eventually the angle is going to just collapse to zero, and then at that point the area is of course going to be decreasing, right? So but initially we don't even know whether the area is increasing or decreasing. So we have to figure out um, what's going on here. All right, let me now write down the given data. So what do we have here? So we know that basically if t is time. So we have three measurements, two sides and one angle between them. So x is a function of t, y is a function of t, and theta is also a function of t. Right, and we are given that the derivatives at the given moment of x, y, and theta. So let me just write it like x like as xt, so which means dx dt at the given moment. So x is, let me see, x is increasing at the rate of 6 centimeters per second, right? So it's 6. Y, the derivative of y with respect to t is going to be, so y is decreasing. So decreasing means that its rate of change is negative. So it's negative 4. And the contained angle is decreasing, right? So the derivative of theta with respect to t is negative 0.05. All right, and then we also know that at the given moment, x is 80, y is 100, and theta is pi over 6. Let me just make sure that everything is measured in the same units. So we have centimeters per second, radians per second. Okay, so which means that we've got to have centimeters here, which is correct, centimeters here, and radians here, which again is correct. So whenever there's pi over something, then it's radians, it's not degrees. Okay, so cool. So all the units are consistent. Here is the given data, and I guess what you also need to know is the formula for the area of the triangle. So which I imagine you must have learned in secondary school. So this is just area is 1/2 x y sine theta. And now we have our chain rule. So basically, we've got to differentiate this area A with respect to t. Now, hypothetically, if we knew the expression for x, y, and theta, we could plug it into a, and then we could differentiate with respect to t, right? So, but the problem here is that we don't know the actual expressions for x, y, and theta in terms of t. So we only know that at a given moment we know their derivatives, so rates of change, and at a given moment we know their values, but how they're changing we don't really know. So which makes it sort of impossible to calculate directly. So we have to use the chain rule. There is no other way. Okay, so let me write down again. So a is uh, 1/2 xy sine theta. Now the chain rule is that the derivative of a with respect to t is um, the derivative of a with respect to x times xt plus the derivative of a with respect to y times yt plus the derivative of a with respect to theta times theta t. All right, so now what is the derivative of a with respect to x? So we just need to differentiate our expression with respect to x. So this is our expression. Its derivative with respect to x is just 1/2 y sine theta times xt plus ay. Now we've got to differentiate this expression with respect to y, and the derivative is, uh, I guess, is just 1/2 x sine theta times yt plus the derivative of the same expression with respect to theta now, and it's going to be 1/2 xy cosine theta times theta t. So equals. Now, and now basically we just need to insert all the given values, right? So these are the given values in the previous slide. So I have copied them onto a piece of paper, right? So I have a copy, but basically it's all in the previous slide. It's in the question itself. Okay, so let me do it. So 1/2 y is 100, right? Y is 100. So times 100 times sine theta. Theta is pi over 6, so its sine is 1/2. 1/2 times xt is 6. Okay, so plus 1/2. Now x is 80 times sine theta is again is 1/2 times yt is negative 4 plus 1/2. x is uh, x is x is 80, y is 100, so xy is 80 times 100 times 100 times cosine of pi over 6 is square root 3 over 2. Theta t is negative 0.05 times negative 0.05. Okay. Okay, and I guess we just calculate everything. So the first term, 100 divided by 4 is 25 times 6 is 150. Second term is, I guess, is even easier. It cancels out, so it's just minus, and it's minus 4. Okay, so minus 4, minus 80. Okay, the third term is also negative, so negative. Okay, what do we have here? 80 divided by 2 and by 2 is 20 times 0.05 is just 100 times 100 is just, right? No, stop, it doesn't make sense. Wait a second. So let me do it like this. 100 times 0.05 is just 5 times 80. 80 times 80 divided by 4 is 20. So 5 times 20 is 100. So minus 100 square root 3. So this is 150 minus 80 is 70, minus 100 square root 3. This is the answer. Okay. I guess you could calculate it in decimal, but it's not required. So I'll just leave it as is. Just one more remark is that 100 is already bigger than 70, and square root 3 is bigger than, is about 1.7 something, so it's bigger than 1 definitely. So 100 times square root 3 is bigger than even 100, not speaking of 70. So the whatever we subtract is bigger than the first term, so the whole difference is negative. All right, so which means that the area is decreasing at the given moment, right? And the rate of change is 70 minus 100 and square root 3. The units should be the same, I guess. So the units should be consistent. So it's square centimeters per second.